Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through similar triangles. So what do we mean in maths when we say that two shapes are similar? It's actually kind of like congruent. You see, we've already learned that two shapes are congruent if they're the same size and the same shape. Now for similarity, they're still the same shape, but they don't need to be the same size. So basically, two shapes are similar if one of the shapes is just a larger version of the other. And that's what we have here. This triangle here is the same as this one, except larger. So these two shapes are indeed similar, whereas these two shapes are not similar. They're not the same shape. And when we're talking about the same shape, we really mean about the angles. These two have different angles, different shapes, so they can't be similar. Again, these two are not similar. This is a rhombus, this is a square. They're not similar because they're not the same shape. One of them isn't just a larger version of the other. In other words, if you wanted to go from this shape to that shape, you couldn't just make this one bigger. You'd have to change its angles as well as changing the size. So we need a more formal way to decide whether or not two shapes are similar. So two shapes are similar if they follow both of these conditions. Firstly, pairs of corresponding angles must be equal and pairs of corresponding sides must be in the same proportion. So when I use the word corresponding here and here, what we really mean is matching. We're talking about matching sides and matching angles. So in these two similar shapes, corresponding sides, we mean like the longest side in each shape is corresponding and the shortest side in each shape is corresponding. Now, what does it mean if sides are in proportion? Well, to understand that, we need to know the scale factor. It's the side in the larger shape divided by the corresponding side in the smaller shape. So, in these two triangles here, to calculate the scale factor, we can go 9 divided by 4.5, so that's side in larger shape divided by corresponding side in smaller shape. As I said, these two are matching because they're the longest side in each shape, or we could do one of the shorter sides, divide its corresponding shape. 9 divided by 4.5, 8 divided by 4 gives you 2. The scale factor between these two shapes is 2. The scale factor tells you how many times longer the sides are in the larger shape. So a scale factor of 2 means the sides in the larger shape are twice as long as their corresponding sides in the smaller shape. If the scale factor was 3, it means the side lengths have been tripled. So when we talk about sides being in proportion, we mean that this scale factor has to be consistent. It has to be the same for each pair of sides. So here we times 4 by 2 to get 8, 4 by 2 to get 8, 4.5 by 2 to get 9. The scale factor is consistent. That's what we mean by sides in proportion. Now, it turns out these two conditions are equivalent for triangles. That means in any triangle, you can't have just one of these. If one's true, then the other must also be true. You can't have triangles that have corresponding angles equal but aren't in proportion. But that's only true for triangles. If we look down here, the scale factor is actually consistent. The scale factor here is 15, side in larger shape, divided by side in smaller shape, 1.25. So the scale factor is 1.25 for each pair of sides, but these shapes are not similar because their angles are not equal. This angle here, a right angle in the square, is not the same as that angle here. So if the shape has more than 3 sides, it is possible to have one of these but not the other. However, in a triangle, if one of these is true, then the other must be true. So let's take a little closer look at triangles. So fortunately, if we need to determine whether or not two triangles are similar, we don't need to check every pair of angles and every pair of sides. Instead, we can use one of 4 tests. So hopefully these tests look familiar. They're very close to the tests we use for congruence. The only difference is AAS is replaced by AAA. So AAS is a test for congruence, but in similarity, we use AAA instead. Now, also important to note, when we were doing congruence tests, the S meant the sides were equal. H meant the hypotenuses were equal. But when we're doing similarity, it means in proportion. So we're saying 2 triangles will absolutely be similar if all their sides are in proportion, or if they have 2 sides in proportion and the angle between them's equal, if all their angles are equal, or they have a right angle and the hypotenuse and another side are in proportion. Okay, it sounds very complicated, but what you'll need to do is you'll get 2 triangles like this and you'll be asked whether or not they're similar. So you're being asked, can I use any of these 4 tests to prove that these 2 are similar? Well, we don't have any information about the angles, so that kind of rules out these 3 tests. Let's check if the sides are in proportion. So the scale factor for the longest side in each triangle is larger divides smaller, 45 divided by 30. That is equal to 36 divide 24 and also equal to 27 over 18. See, if you put any of these in your calculator, you get the same number of 1.5. The scale factor here for these 2 triangles is 1.5. It is a consistent scale factor. Same scale factor for the shorter side, for the middle side, and for the longer side. So we have 3 pairs of sides in proportion, so these 2 triangles are similar by the SSS test. What about these 2 triangles here? Well, now we don't have any information about sides. When you don't have enough information about sides, it really only leaves AAA. See, here we've got this angle's 50, this angle's 30. But because the angles in any triangle add to 180, this angle here must be 100, because 100 plus 50 plus 30 is 180. Now, this is enough to prove that these are similar by the AAA test. In fact, when you do the AAA test, you really only need 2 pairs of angles, because if you have 2 pairs of equal angles, the third angle must also be equal. The third pair of angles here has to be 50 because of the angle sum of a triangle. So these 2 are similar by the AAA test. So you might be asked to write a similarity statement. This is how you write it. So we're going to call the first triangle according to its vertices, so I'm just going to call it ABC. Now, when you want to show 2 things are similar, you either use that symbol or this symbol. Doesn't matter which one. I'm just going to use this one. All right, now when we're writing the second triangle, we need to line up the vertices. So A is where the 100-degree angle is, so it corresponds to E. Because I wrote A first here, I need to write E first in the next one. So B is where a 50-degree angle is, so it corresponds to F. They have the same angle there. So because I wrote B second, I write F second in the second triangle, and then of course I write D. And then in brackets, I just write the test AAA. All right, let's now use similarity to find sides. So let's look at these 2 triangles here. It turns out they are similar. So why are they similar? Well, if you go 8.4 divided by 6, you get the same answer as if you go 5.6 divided by 4. Both of these equals 1.4. The scale factor is 1.4. This is 1.4 times that one. This is 1.4 times that one. Now notice that this angle here and this angle here, they have to be equal because they're vertically opposite. So these 2 triangles are similar by the SAS test. Now if they're similar, it means that sides will be in proportion. So we can find an unknown side like x. Now we need to use this rule here. If you're finding a side in the smaller shape, you divide by the scale factor, and in the larger shape, you multiply by the scale factor. We're finding a side in the larger triangle. So what we do is we take its corresponding side and we times by the scale factor. The scale factor is what we calculated there. So if you put that in your calculator, x will be 12.6 and we're done. All right, this one here is much harder. So these two triangles are similar because we have one pair of corresponding sides over parallel lines, two pairs of corresponding angles over parallel lines, and as I said, if you have two pairs of equal angles, that's enough to use the AAA test. So here we have that this triangle and this triangle are similar by the AAA test, so their sides must be in proportion. So the scale factor is side in larger shape divided by side in smaller shape. Larger over smaller, which is equal to 1.75 if you put that on your calculator. All right, let's find x. So side in smaller shape times the scale factor must equal the side in the larger shape. Well, the side in the larger shape, this side here, is actually x plus 6. So we have x times 1.5 equals x plus 6. Now, lucky we did so much work on equations. We solve this by subtracting the x with the lowest coefficient. We're going to subtract x from both sides. So we get 0.75x equals 6. How did I get that? Well, this is a 1x. 1.75 minus 1 is 0.75. So if we now divide each side by 0.75, we get x equals 8, and we are done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.